Okay, lesson 18, similarity in the angle bisector theorem. Let's do a little review. First of all, what is an angle bisector? I could draw a picture. An angle bisector cuts an angle into two equal pieces. Let me write it in words. A much fancier explanation. The bisector of an angle is a ray in the interior of an angle that the adjacent angles formed are equal. Describe the angular relationships formed when parallel lines are cut by a transversal. Hold on a second. All right, when you have two lines cut by a transversal, two parallel lines cut by a transversal, the corresponding alternate interior and alternate exterior angles are all equal. The same side interior angles are supplementary. That means they add to 180. What are the properties of an isosceles triangle? Draw one here. Basically, an isosceles triangle has two congruent sides and two congruent base angles. And those would be the angles opposite the congruent sides. Okay, discussion. In the diagram below, the angle bisector of angle A and triangle ABC meet side BC at point D. Does the angle bisector create any observable relationships with respect to the side lengths of the triangle? I'm just going to highlight a few things. I have side BD and CD. Let's see, let's make them different thicknesses. And then if you can look at BA, oh, that's huge. Oh, that's a little bit better. I'm comparing thicknesses. So if we compare skinny red highlighter to skinny blue highlighter and thicker red highlighter to thicker blue highlighter, what do we notice? It's true, we have a scale factor of 2 or 1/2, depending on which way you look at it. So that's pretty cool. So we have an angle bisector, and that's what I can see that's sort of equal. Okay, BC isn't very interesting, but if I compare, let me just write it down, BD and CD, and then BA, the ratios, I can see that I am 2 to 1. Okay, let's prove why that is true. I'm going to draw a line, which is very hard to do, so I'm making it a highlighted line. Right there, it's through point C, and I'm going to make this point E. Okay, what we are proving here is the angle bisector theorem. Okay, I'm going to write down some things and then we'll talk about it. I'll be right back. So the angle bisector theorem states that in triangle ABC, if the angle bisector of angle A, right here, of angle A, meets side BC at point D, then the ratio of BD to CD is equal to the ratio of BA to AC. So we can prove this. First of all, this line I drew up here, let's put it back. This line is parallel to that line because that's how I drew it. So we know that angle CED is congruent to angle DAB. Okay, and basically if I can prove that triangle, up here, the blue one, is similar to this triangle, then life is pretty grand. And what's really cool is I've got some vertical angles here too. So we know that angle CED is equal to the measurement of angle DAB and the measurement of angle CDE is equal to measurement of angle ADB because they're vertical. Then I know the triangles are similar because of angle-angle similarity congruence, right? Cool. And if I know the triangles are similar, then I know the sides are going to be similar. Okay, that side's going to be similar, not congruent to that side. These are similar, not congruent. We know that because they're measured. And these are similar, not congruent. Because once I prove that the triangles are similar, then the corresponding parts are also similar. Cool. We just proved the theorem. All right, let's try an exercise. There's 4 of them, as you can see. You can look through. I think I have 5, 6, 7. Yep, I only have 4 slides left. So this one says the sides of a triangle are 8, 12, and 15. An angle bisector meets the side of length 15. Find lengths x and y and explain how you arrived at your answers. So I can set up a pretty simple proportion. If I do y over x, so y over x, I can do 12 over 8. Okay, can do, oh, if the whole thing is 15, I didn't see that. This whole thing is 15, let's put one of those pieces in terms of the other. So I can say x is equal to 15 minus y. So let's go ahead and do that. Y over 15 minus y equals 12 over 8. Okay, go ahead and do a cross product. 8y equals 12 times 15, 180 minus 12y. Add 12 to both sides. I have 20y, oops, it's 180, equals 180. Y equals 9. X equals 15 minus y. X equals 6. Cool. And I know my answers because I know the angle bisector theorem makes proportional sides or similar triangles. So I just set up my very simple proportions and solved the triangles. The sides of a triangle are 8, 12, and 15. An angle bisector meets the side length of 12. Find x and y. Again, x over y is going to be 8 over 15, or I can say y over x is 15 over 8. And then I'm going to put one one variable in terms of the other. So let's do 15 over 8. So I just did 15 over 8, so I'm going to do y over x. And let's put x in terms of y. If the whole thing is 12, let's say y equals 12 minus x. I think that's what I did last time. Oh well. Let's go ahead and substitute 12 minus x over x. Do our cross products. 15x equals 96 minus 8x. Add 8 to both sides. And then divide. I think I can do that without a calculator. Nope. 96 divided by 23. Yikes. X equals, I got 4.2. I'm sure a fraction will probably make that easier. So y is going to be 12 minus x, or 12 minus 4.2. 7.8. All right, number 3, the sides of a triangle are 8, 12, and 15. An angle bisector meets the side length of 8. Find lengths x and y. Okay, so let's do something crazy. I'm going to do 15 over y equals 12 over x. And if the whole thing is 8, I can say y equals 8 minus x equals 12 over x, cross product. 15x equals 96 minus 12x. 96 equals 27x. Divide both sides by 27. X equals 3.56. Y equals 8 minus x. Y equals 4.44. Well, this one's sort of messy. I drew a picture and I think it's right. Let's go ahead and try it. I'll set up my simple proportions. X over 6 equals y over 5. Let's go ahead and solve for y and substitute. So x over 6 equals 33 minus x over 5. Cross product. 33 times 6, 198. Minus 6x, so 198 equals 11x. X equals 18. Y equals 15. Awesome, that was sort of fun.